Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with soil mechanics in the topic of effective stress. So the problem is a sand stratum is 8 meter thick, the water table is 1 meter below the ground surface, then G equal to 2.7, E equal to 0.7, that is void ratio equal to 0.7, then the capillary rise above the water table is 1 meter. So we have to find out the variation of total stress, neutral stress and effective stress for the sand stratum. So first we have to draw the sand layer. One layer is there, so that is a sand stratum. So from that sand stratum, so 1 meter below the ground surface there are water table. So this is the ground surface. So it's a ground level. Then 1 meter below there is a water table over there. This is 1 meter. So this is the water table. So we have to find out the 8 meter thick. So the total thickness is 8 meter. So the sand stratum is 8 meter thick. So total 8 meter. So the remaining portion is 7 meter. So from that there are two layers are there. So from that we have to find out the effective stress, total stress and neutral stress. So first we can name the layer A, then this is the B and this one C. First we have to know the soil properties, that is sand property. For calculation of total stress, neutral stress and the effective pressure, we have to know the unit weight of sand. So unit weight of sand gamma equal to so gamma S equal to G plus E into S into gamma W divided by 1 plus E. So we know the formula, so we can substitute all the values. So G is given 2.7 plus E value is 0.7 into, so the S value is 1 because it's completely saturated, because there are saturated water over here and also the capillary water also over here. So there's a fully completely saturated sand layer. So we can put S equal to 1 into, this is 9.81, so gamma W value is 9.81 we know. So 1 plus 0.7. So solving this we got the value of gamma S value, so gamma saturation value. So gamma saturation equal to 19.62 kilonewton per meter cube. So this is the value we got from the formula. So then now we going to calculate the total stress, neutral stress and effective pressure of the each layer. So first we can take at AA. So AA layer we have to take. First thing we have to calculate the total stress. So there is no stress above the layer because there is nothing over the A layer. So we can put the total stress equal to 0. Then mu, so that is neutral stress. So neutral stress is pore water pressure. So the only pore water pressure is acting on the mu value. So from mu value, so there is no water over here, but the capillary rise over here. So the capillary rise is above the water table is 1 meter. So we have to consider this. So we can put minus 9.81 into, so the total thickness of the layer so equal to 1. So now the total value is minus 9.81. So now the effective stress value, so effective stress equal to, we know the formula, total stress minus pore water pressure. So now 0 minus of 9.81, so equal to plus 9.81. So this is the value, this is the stresses in AA layer. After that we can calculate the BB layer. So at BB we have to calculate the total stress, effective pressure and pore water pressure. So then sigma equal to, so at BB, so the stresses due to this sand will act on the BB layer. So from that gamma saturation into H1. So this is the H1 value and this one H2 value. So from that we can calculate the gamma saturation equal to 19.62 into the H1 value is 1. So total value is 19.62. Okay, so now the effect pore water pressure. So we know the pore water pressure at water table is 0. So we can put 0 over here. So then sigma dash equal to sigma minus mu. So the sigma value is 19.62 kilonewton per meter square minus 0. so equal to 19.62 kilonewton per meter square. So this is a total stress, effective pressure and pore water pressure in BB layer. So likewise we can calculate the CC layer also. So now at CC, so we have to calculate. So the sigma value is gamma saturation into H1 plus, so there is a sand over here, so we can put this layer also, gamma saturation into H2. So now the gamma saturation value is 19.62 into 1 meter, again plus 19.62 into 7 meter. So the H2 is 7 meter. So now mu value, so mu is equal to gamma W into H2. So the only water table is H2 is a water table. So here only the capillary rise over here. So we don't consider the capillary rise. So gamma W is equal to 9.81 into the value is 7. So sigma value is 156.96 kilonewton per meter square. So from that mu is equal to 9.81 into 7. The value is 68.67 kilonewton per meter square. So after that sigma dash value, so sigma dash equal to sigma minus mu, we know the formula. So sigma is equal to 156.9 minus 68.67 the mu value. So totally we got the value of 88.29 kilonewton per meter square. So this is a sigma dash value and mu value, then sigma value. So this is the method we can solve the effective stress problem. Again we will see in next video. Thank you.